All right, good morning, ladies and gentlemen. Welcome back. Today we're going to be looking at oxidizing and reducing agents as we continue our discussion and our walkthrough on electrochemistry. And I just wanted to give us a brief recap of what we looked at last time. Now, if you remember last time, we looked at how to assign oxidation numbers. And we defined oxidation and reduction. As we can see here, oxidation is the loss of electrons. Reduction is the gain of electrons. Remember, I gave you guys the mnemonic oil rig, or Leo the lion goes grr, to help you remember that. And the last thing here that I think is important to recognize with redox reactions is that you can never have one without the other. So, for example, if you have a redox process, there's always going to have a reduction and an oxidation. There is never going to be just an oxidation or just a reduction. Okay, and that should help us moving forward as we begin to look at redox reactions more. Now, today, what I want us to be able to do is to build onto kind of the understanding and the foundation that we built last time and take a look at what is an oxidizing agent and a reducing agent. And so here, we just get very plainly that an oxidizing agent is the substance that's reduced, and a reducing agent is the substance that's oxidized, okay? Now, just quick reminder, redox reactions always have the simultaneous oxidation of one reactant with the reduction of another through the transfer of electrons. And we saw this previously when we were balancing redox reactions. Not only did we have to balance them for mass, but we also had to balance them with charge by making sure that the number of electrons that were being transferred was the same on both sides. Now, in a redox reaction, when you look at your reactant side, the reactant that causes the oxidation of the other reactant is called the oxidizing agent. Now, since it's causing the oxidation of a substance, remember, oxidation is the loss of electrons. So the reactant that is causing an element to lose electrons, it has to be the substance that was reduced. So this is going to be called the oxidizing agent. Now, of course, your oxidizing agent and your reducing agents can be ranked. Some substances are much better oxidizing agents. They're much better at causing other elements to lose electrons than another. And we'll look at that later. Now, the reactant that's causing the reduction of the other reactant is called the reducing agent. Now, in order for reduction to occur, that means the substance has to gain electrons. So the reactant that is causing another substance to gain an electron is the reducing agent. That's the substance that's oxidized, right? Because when a substance loses electrons, it's gained somewhere else, right? And so just like oxidizing agents can be ranked, there are going to be certain elements that do a much better job of causing a substance to lose electrons. There are also going to be substances that are much better at reducing or acting as a reducing agent. So that means that they're much better at losing their electrons as opposed to gaining the electrons, right? So just kind of keep that in the back of your mind. So now that we understand that, our goal should be, can we confidently identify something as being oxidized and reduced, and can we identify it as a substance as an oxidizing or a reducing agent when we're given a redox reaction? That's kind of where we're going from here. So when we think about this, if we can determine one of those pieces of information, if we can figure out what was reduced or what was oxidized, right, that's going to help us determine what other substance was then oxidized or reduced, whichever one you found, and whichever one's the oxidizing and the reducing agent, right? So once we can figure out one of these things, the other pieces fall into place pretty easily. And so just as a quick reminder that if it gets reduced, it's your oxidizing agent. If the substance is oxidized, it's your reducing agent, okay? So let's take a look at an example of how we would identify an oxidizing or a reducing agent. So if we look at the following reaction, you've got the reaction of aluminum with lead 2 chloride producing aluminum chloride and lead. So in order for us to identify the oxidizing and reducing agents, we're going to need to first identify the oxidation numbers for all of our substances in this particular reaction. Now, so we write down those oxidation numbers, and when we do that, we should find that the aluminum on the reactant side has an oxidation state of 0. The lead has a +2 in the compound, then -1 for chlorine in the compound. Moving over to the product side, the aluminum has a +3. The chlorine in the compound has a -1. And our lead has an oxidation state of 0. Now, from that, we can now easily identify what substances were oxidized and what substances were reduced. And so our substance that was oxidized is the aluminum, right? Aluminum went from a 0 oxidation state to a +3. It was oxidized, so it is the reducing agent, right? So it lost electrons. It allowed for another substance to be reduced because it took the electrons from aluminum and transferred them to the substance that was reduced. Now, in this case, our substance that was reduced is going to be the lead that was in the compound when it got converted over to the lead element, right? So lead went from +2 to 0. So it was reduced, it gained electrons, and so it is our oxidizing agent. It is the substance that facilitated the aluminum being oxidized, right? Now, it's important to recognize here that when we identify substances as their oxidizing and reducing agents, we look at the entire substance as a whole, not just the individual element that was changing, right? So like for the aluminum, for example, we would call that the reducing agent because specifically aluminum was the reactant that we had. But for the lead, yes, that was the substance that was reduced, but we would say that the lead 2 chloride as a whole is the oxidizing agent, not just the lead as the element, because then we'd be referring to the product side, and that would cause some confusion. So just kind of keep that in mind. It's the whole compound, not just the element. Now, another real quick example with oxidation numbers. You need to identify the substance being oxidized and reduced. This one should be pretty straightforward. You've got 2 elements, and then you've got 2 monatomic ions. So the elements all have oxidation numbers of 0, and your ions have the oxidation state of their charge. So copper goes from 0 to +2, so that means it was oxidized, which means that copper was the reducing agent. I do, and that means that the silver goes from +1 to 0. It got more negative, so it was reduced. So the copper was the reducing agent, and silver was the oxidizing agent, right? And so, again, understanding this idea of an oxidizing or reducing agent is really important as we begin to move forward and we start to look at voltaic cells and we start to look at standard reduction potentials, because it's going to help us understand what's going to be best at being oxidized, what's going to be best at being reduced, and how we can use that information to put together a voltaic cell that is going to be spontaneous and has a positive E naught value. And we'll get into that more as we go forward. But for now, thank you for joining me. I hope this was insightful. That was my son, by the way. Hopefully that doesn't distract you too much, and we'll see you guys again real soon.